But I would also say it's an opportunity for us as a community to come together and say, well, hey, what next, right? What could we be doing to pursue the course of advanced computing technology within the NSF and US research community? With that, I'm actually just going to pass it back to Ava and let's get things going.
Okay, great. So that all of you know, we will record these sessions and we'll also put them later on the webpage in case you want to have a look again at that. So I will start with a kind of general presentation about Ookami to bring all of us to the same level, what the system actually is. So Ookami is a computing technology testbed funded by NSF, the National Science Foundation here in the US, for all of you who are not in the US. And it's available for researchers worldwide, excluding some countries. And the usage of the system is actually free for non-commercial and also for some limited commercial purposes. The name of the system, Ookami, is a Japanese word, and it's the word for wolf. And that's an homage to both the origin of the processor, which is a Fujitsu processor out of Japan, and to the mascot of Stony Brook University, which is a sea wolf, as you can see here in the picture. We are operating the cluster here at Stony Brook University at the Institute for Advanced Computational Science, and we are cooperating with the University at Buffalo. The motivation for Ookami is the huge success of the Fugaku system. As most of you probably know, Fugaku is the fastest machine worldwide, so it's scoring #1 in the top 500 ranking. But not only that, it's scoring #1 in all 5 major benchmarks, meaning the system is suitable for a wide range of application, and it's also power efficient. Here you can see a picture of what Fugaku looks like. It has around 160,000 nodes. And if you keep that now in mind and compare it to Ookami here, you can see that Ookami is much, much smaller. Ookami is around 1,000 times smaller than Fugaku. It has 176 compute nodes, or Fujitsu A64FX nodes. And those are nearly the same as in Fugaku. There are a few differences because Ookami is using the FX700 series, whereas Fugaku is using the FX1000 series. And the main differences are, first of all, clock speed. Fugaku is running at 2.2 gigahertz and Ookami at 1.8 gigahertz. And also the chip in Fugaku has 1 additional core per CMG per core memory group. So 13 per core memory group and 12 we have in Ookami. I'll go into detail on that a little bit later. So as I said, we have this Fujitsu A64FX nodes, and they are running with 32 gigabyte high bandwidth memory. And each of the nodes also has an additional 512 gigabyte SSD. The Ookami system is the first deployment of this technology outside of Japan, and it's an HPE Cray Apollo 80 system. It's a testbed, and it also has some other technology inside to allow comparison between chips. For example, there's one node with a dual socket AMD Rome node and 2 nodes with dual socket Thunder X2. Those are actually the login nodes. So if you log into this Ookami, you immediately jump onto a Thunder X2 node. There are also 2 NVIDIA V100 GPUs and 1 Intel Skylake processor. Summing all of this up, the system delivers around 1.5 million node hours per year. And here we can have a look onto the chip in a bit more detail. So here you see a picture of the Fujitsu A64FX chip. It's an ARM-based node. And the key features, one of the key features is that it has a low power consumption. So it supports high calculation and needs very little power for doing that. It's also the first chip which supports scalable vector extension, SVE, in this case with a vector length of 512 bit. The chip consists out of 48 cores, and these 48 cores are divided into 4 core memory groups. So each core memory group, or CM3, consists out of 12 cores. And as I said, in Fugaku, that's a bit different. There it consists out of 13 cores, 1 additional core for the operating system. 64 kilobyte of L1 cache per core, 8 megabyte of L2 cache shared between all the cores. And the third key feature is the high bandwidth memory of 32 gigabytes, running at around 1 terabyte per second. And here you can see the like detailed numbers of the chip, like the cache, the memory, and all of that. And if you're interested in all of that, that's on our website, so you can go through it in each detail and see all these numbers. What else is there to say about Ookami? So it's running standard Linux as operating system. We currently have CentOS 8. This might change in the future, but at the moment we have CentOS 8. There is 2 authentication in place, a high performance loss to file system, and the system has around 800 terabyte of storage. For job scheduling, the Slurm workload manager is used, enabling a fair share policy between all the users and all the jobs running. There are different compilers on the system. And for the A64FX nodes, we have the GNU compiler, ARM, Cray, and Fujitsu. And for the other nodes, like for the Intel Skylake and for the GPUs, we also have the Intel compiler and the NVIDIA compiler available, and different versions of all these compilers. On Ookami, there is a module environment set up with a pre-installed software stack, which we're always trying to keep up to date and to add whatever might be beneficial for users. So there are, for example, various flavors of MPI or MAF libraries, are also profilers or debugging tools available. During the time we used the system, we had some key levels, like from a bird's view, which we want to share with you. And you will probably share much more detailed key findings than us. It's just to give you an overview of what we think is important on the system. So the compiler makes really a huge difference in performance. That's why it's important to test all the available compilers for your application. As a general finding, we see that Cray and also the Fujitsu compiler deliver the best performance. ARM also delivers competitive performance and has huge advantage. It fully supports current language standards. And for the GNU compiler, we see that most people who are new to the system, who just come onto it, they start with using the GNU compiler. And here it's like a two-sided thing, because it can generate really good optimized code using SVE and giving good performance. But it has one major drawback, which is the lack of a vector MAF library, which can really harm performance depending on your application. And now to give you a bit more broader context, also for those of you on the call who are new to Ookami and who want to learn more about it. So the system, or the whole project, started in 2019. Then Ookami was procured, all the different things of it installed here at the university. And then we had early user access, so friendly users who tested the system and help us getting it to run. Since last year, the system is open to the public, and that's just for testbed projects. And I will explain later on what's the difference between testbed projects and production projects. And from this year onwards, we also welcome production projects on the system. And in the future, in October, we will be integrated into Exceed, and allocations will also be hugely done through the Exceed network. And to give you a feeling who all your colleagues are, who you have to share the queue with and who you see their jobs running. At the moment, we have 211 users, some of them more active, some of them less active, obviously, in 71 projects. Most projects are from universities within the US. We also have a few projects from Europe And as we said, the system is open worldwide, so all other continents are also welcome to use it. And most of the projects are from academia. We have a few industrial projects too. If you're interested in who is using the system, you can have a look at a list of all the projects on our webpage and have a look what they are doing on Ookami. We are trying to help the users, and there is user support available, and it's a multi-level thing. So using A64X can be tricky, and so user support is really important, and we also encourage you to get in contact with us. We have a Slack channel, which most of you probably know, where you get hopefully nearly immediate response either of the project team or from some other users who ran into a similar problem. There is the ticketing system. That's probably more for conventional stuff like software installation requests or account requests, stuff like that. We're organizing regular webinars to help users and to show them things that we think are beneficial for them, like different software and different tools like profilers and stuff like that, and to also put A64FX in a broader context. All of these recordings and slides are also available on the website. And the last thing, which I really want to advertise a little bit more, because I think it's enormously useful, are the virtual office hours, which we are holding twice a week. Those are Zoom meetings on Tuesday and on Thursday, each of them for 2 hours. And there's always somebody on this call. Those are very informative meetings. You can just drop on and off whenever you want, as long as you want. There is no need to stay the whole 2 hours or to join directly at the beginning. Just hop on and off whenever you want. And I think those are really, really helpful because you might have a lot of questions. You don't know which modules is the best or anything. We'll try to answer these questions if we know them. And if we don't know the answer, we will help figuring out what's the right way to do things. So really drop in and join us there and just get in contact with us. We are happy about that. The allocations. So currently all allocations are through Stony Brook University. And some of you might already have noticed, because I got in contact with you, that accounts have to be renewed once per year. And as I mentioned before, Ookami is currently in the process of becoming an Exceed Level 2 service provider. That means from October onwards, around 90% of the computational time will be allocated through the Exceed network. What does this mean for the current users of the system? There won't be a lot of change. So you will still be able to use the system, though your jobs might be reduced in priority. So Exceed jobs will have higher priority than jobs of users who are currently running testbed projects on the system. And if you're here for learning about Ookami and you think about getting an account on the system, that's actually pretty easy, the process. So if you have a look onto the website, you will find a template for project requests. And you can either ask for a testbed project or a production project. And testbed projects are mainly for porting and tuning software, for doing some limited benchmarking, and can use up to 15,000 node hours per year. And during the first 2 project years, which are like currently running, those are the majority of all projects. And then there are the production projects, which can use up to 150,000 node hours per year. And especially at the moment, those have lower priority than the testbed projects, to give everybody the chance to test the A64FX nodes for their software. So if you submit a request, we will review it. We will see if everything is okay, if there are any questions, and if the project is accepted, the request will be published on our website, and you will get accounts on the system and can use Ookami for free. The last thing I want to mention is how you can get in contact. And I think most of the questions you might have will be answered on our webpage. So have a look there and scroll through all the different pages. And if there are questions which are not answered, there are a few other ways to get in contact. Either the ticketing system, which is more for technical questions or software installation requests. Our Ookami email address, which is okami_computer@stonybrook.edu, especially for those of you who don't have an account yet and who have any questions. As I said, the office hours twice a week and the Slack channel. And with that, I'm finishing my presentation, and